Dnes si představíme ElaadNL, holandskou neziskovou laboratoř chytrého nabíjení elektromobilů, jejich vlivu na distribuční síť, chytrého řízení nabíjení tak, aby nedocházelo k lokálním výpadkům té sítě a budoucnosti energetiky v kontextu nabíjení elektromobilů, respektive dodávky elektřiny z elektromobilů do sítě a také témat kyberbezpečnosti. Vítejte na kanále Electro Dad, jsem Jan Staněk a od roku 2019 se snažím inspirovat milion lidí k přechodu na elektromobil a čistou energii.
Hi, my name is Baertem de Brey.
I'm Mariscou Zweistra.
You're at ElaadNL Test Lab today. ElaadNL is founded in 2009 as a collaboration of grid operators, and we are very well known for OCPP.
Yeah, sure. And we're also very well known for our testing lab, which is where we are currently. And at the moment, we're actually preparing for a big test event where over 100 people with cars, chargers, and software systems will be coming to test their systems and to make sure that everything works smoothly together.
Yeah, you might know the Netherlands is a bit advanced on e-mobility rollout, but also interoperability. That's what we're testing next week. Your car with my charger and your car with my charger. Does it all work? Very important for a smooth and convenient rollout. But first we'll show you how we've come to this test lab. As you can see, it's quite big, so it's not only for personal vehicles, but also prepared for trucks and buses, because in a few years they will hit the Dutch market, but also the market in Central Europe.
So what we're about to show you now is the very first chargers that we had installed in the Netherlands, where we have already seen quite a lot of development, because in the early days we used to have chargers like the one you see here on the left, where the actual charging was separated from the grid connection, and that's not so convenient.
Yeah, as you can see, also one of the footage taken here in the Netherlands is with the EV box. This is one of their first chargers, and it only had a charger, but then we grid operators said, well, you want to do some measurements as well. So a separated meter was welded on it. So this is a little bit of the history. Well, it doesn't really look fancy and is not very scalable. So a next version was with the integrated meter in it. Many more components in it, but as you can see, an old-fashioned charging station with traditional fuses. And when there was a disturbance, an engineer had to go out and change the fuses, which is labor-intensive and very costly. So municipalities did tenders saying, no, we want to have that digitalized, electrified.
Yeah. So that's what you see going up the line in more modern chargers. They become smaller and they become more controllable. So that also made it possible to do smart charging, which is basically what we started to do once we had a sufficient population of EVs and chargers in the country. We decided that this was actually an opportunity for us to have some sort of influence on when the charging was actually taking place. We could take into account the amount of sustainable energy that was being produced, the energy prices, or the availability of power on the grid. Because this charger is now connected to the internet, we can send control signals to every single station, which makes it much more usable, basically.
Yeah.
And
maybe one addition, smart charging for grid operators, as we are, is important to keep the system in balance, so no overloads on the cables, align it with solar generation. But grid operators also have the responsibility to facilitate the market. So even if you have a very stable grid in your country, it's important that consumers, EV drivers, might earn a little bit of money with the future with vehicle-to-grid, for example. Charge your vehicle when prices are low and discharge when prices are high. Regardless if the grid is stable or there are some peaks or dips, that is also important on smart charging.
Yeah. Well, and one more innovation that we recently developed is what we call the compact connection, because we have now such a high growth rate of electric vehicles and electric chargers that our engineers out on the street were really struggling to get all the chargers in place in time. So there was a lot of waiting going on. Like Bart is showing here, this is what had to be made every single time that a charger was connected, and it took a lot of time. It took over half an hour to connect a single charger.
So this is the cable, normally in the street, looks like this. You see the different phases. You had to cut it a little bit, and then you have to take this extra cable off where the charging station is on.
Yeah.
Labor intensive and,
yeah.
and thus costly.
Yeah, and that's why we changed it to what we call the compact module, where actually it's sort of like a plug and play. It's just once you have the cable coming out of the street, you can just put a charger in, and it reduces the amount of labor massively to like 7 minutes for installing the actual charger on the street. So that's also some of the work that we do, and we also have trainings here for the grid operators to
this is, by the
teach
way,
them.
What it looks. Can't open it because, well, that's safety. It's very efficient
You see
to
it here.
plug it in, but also you can plug it out, might plug it out, and kids play with it and could get electrocuted, but this way they can't put their fingers.
Yeah.
And so it's not only efficient usage, but also very safety concern.
You can just leave this out on the street, and whenever the charging station arrives, it can be put there quickly. And that's really nice, but it also needs a lot of training for the engineers. So we invite all kinds of engineers here to have training in this type of work or in any other work on the charging stations.
Yeah. These are some public chargers. Like any other country in Europe, the first rollout was often, well, with the early adopters who could afford an expensive vehicle. Keep in mind that the majority of the population in the Netherlands lives in houses without their own private parking. So therefore we focus very much also on the large majority, on the normal EV drivers who might not have an EV yet, but in the coming years, 70% of households are dependent on curbside charging in the Netherlands. We still focus also on wallboxes, maybe for the early adopters at their houses, but also at offices. Interoperability is very important for Dutch consumers, and as you can see here, many different suppliers, and what we do here is test them on functionalities.
Yeah, so what we test is what the charging actually does to the power quality on the grid that the charger is connected to. We test whether the car is actually responding accurately to whatever signal is sent to the charger. And we also check for efficiency of the charging sessions, like if you reduce the power, what happens with the amount of power that actually goes into the car. And some of those chargers, not one of the ones here, but they can also do the vehicle to grid charging that Bart already mentioned. And then of course it's also interesting to see whether or not there is energy lost. Well, there will be some losses, but you want to minimize that, so that's also something that we test for. And well, the collaboration between all the different control systems that could be in place connected to this type of charger. You can have a multitude of back offices. That's also very important to see if it's all interoperable, and this wall keeps changing. If you come here in a year, there will be different chargers here, because we just invite everybody to bring their hardware here, and we'll test it for free, just to make sure that everything functions within the standards of the grid operators.
Yeah, and that is important because, well, the trend, the economy of driving electric is there. You see many more modules on the market, the prices of EVs drop, but you also see Brussels legislation hitting the market. Some countries are a bit quicker with implementation, but 3 big regulation packages are important, which I would like to share with you. The first is the alternative fuel infrastructure regulation. It's come to the market this year, and it's stating some numbers on smart charging, for example. Every charging station has to be smart. It's also saying some things on fast charging. You can see some fast chargers over here. Also tested in our test lab. And the alternative fuel infrastructure regulation says that every 60 kilometer of highway, it has to have a fast charging facility. So regardless if you're living in the Netherlands or in the Czech Republic or Slovakia, Spain or Greece, this will happen. And of course, if you're on a holiday, you want to be able to charge either in Bratislava, Prague, or in Amsterdam. But also keep in mind the future market of trucks. So logistics also is dependent on, well, these chargers or mega chargers. A second part of legislation is regarding the home chargers, the European Performance of Building Directive. And well, we would really like to see that also there is some European checks on, are the home chargers also smart chargers, because that's out of our span of control. Municipalities doing tenders, we can help them with specs on smart charging. So there's the municipality technical specs responsible for the smartness, but the home smartness is something of the willing consumer. And of course, to keep the grid in balance and to keep the consumers safe and cyber secure, that is still a thing to do for European politicians. And a third, and we might go upstairs to our household, is the Renewable Energy Directive. So this lab isn't only about electric vehicles and testing them and testing the hardware to charge them, whether it's curbside charging, home charging, office charging, or fast charging along the highways. It's also the integration with solar panels and heat pumps, because in the end it's not only about clean mobility, but it's achieving climate goals and improving inner air quality.
So what we built here upstairs is actually the home of the future, where we are preparing for households that have the full package of electric vehicle, solar panels, heat pumps, electric cooking. So they have a lot of electricity usage, and all of that has to be controlled to stay within the capacity limits of the household, but also needs to be controlled to stay within the capacity limits of the grid on which the house is connected. So what we have here is actually what you would have in a house in that near future, where you could have a heat pump, a solar panel inverter, and stationary battery over there.
Yeah.
And we also here we invite the engineers to come and work with it, because what's really important is that you are already living somewhere and you decide to change your battery or to add a battery or to go from gas heating to a heat pump. You want your house to be manageable. You don't want to have vendor lock-in, that you have to use a certain type of software to be able to heat your house. And you also want your battery to be speaking to all the other components. So that's what we're testing here. And what's really important in that respect is also that all that communication that takes place is cyber secure. And I think that's what you also wanted to mention.
Yeah, cybersecurity is very important, but on interoperability, one more note. It could also be that a first-hand vehicle, so a new Tesla or a BMW, is sold in the Netherlands, France or Germany, and it is on the second-hand market in Central Europe or South Europe. And what you want to avoid is that you can do bidirectional charging in the Netherlands, for example, but you can't at the new location where the vehicle is driving. Or a second thing is, if I'm driving, say, a German electric vehicle, but I'm selling my house and I got everything in line, my solar panels, my heat pump, my battery and my charging station, and it all works. But the new owner of my house drives a French electric vehicle or an American electric vehicle, Chinese electric vehicle, and he has to remove all the solar panels and renew them because it's not functioning at a proper way. Well, that is hindering the rollout of this innovation. So therefore we focus very much on standardization and interoperability.
So before we go into cybersecurity, I also would like to show the immense square meters of our venue, which we also use a lot to invite all kinds of parties who have some sort of meeting or want to do some knowledge sharing. They can all come here and use our venue, be in the middle of the electric vehicle mobility transition, and have an inspiring session here.
Cybersecurity, the elephant in the room, because we've only been talking about the opportunities that there are. Electric vehicles are becoming cheaper. They might help increase the stability of the grid, and thus it helps achieving climate goals, improves inner air quality. You might even earn a little bit of money with vehicle to grid. But yes, these are opportunities, but if you reverse it and you start charging when there already is an energy peak on the grid because your charging station is compromised, is hacked, then you do the opposite. And in, well, the one case, your vehicle isn't charged in the morning when you want to go to the office, or a supermarket can't be supplied because all the charging stations are hacked and the trucks delivering all the milk and the bread can't drive. That is inconvenient, but in the Netherlands we already have over 140,000 public charging stations, all of 11 kilowatts. So all those charging stations together have a power of over a gigawatt. And in a few years we want to have over 1 million public charging stations and over 3 million electric vehicles on the road in the Netherlands. At the moment we have, I think, over 600,000 electric vehicles. So 600,000 electric vehicles, if you hack them, that is 6 gigawatt. And 6 gigawatt, if you turn it on and turn it off and turn it on and turn it off, you blow up the grid. You cause an outage, but you might also damage the distribution transformers and everything behind it. So cybersecurity not only keeps the bad hackers out who might go for some ransom, but it might also it has to prevent your grid from causing the opposite effect and damaging it. So here in our lab, we create cybersecurity specs. They're downloadable on the ElaAD website under publications, and we recommend municipalities or big organizations who do tenders to check these cybersecurity specs, because, well, if the grid in the Netherlands is compromised, it's interconnected with other European countries. So a problem in the Netherlands is not only a problem in the Netherlands, it causes a cascade of events. Okay, back to the normal, to the opportunities. You want to show grid shield.
I want to show something that we developed. in addition to all the smart charging and testing that we're doing, we're also preparing for a future in which smart charging by itself might not be enough to keep the grid in good condition. And also because there might be so much energy demand that we have to do some extra safety measures to help in the stability of the grid. So what we basically have is a future in which everybody drives electric or wants to drive electric and has a controllable charging station. So they all have their own durable energy, they have their own agreements with parties that control for them when the charging is taking place based on cheap energy prices, their own local production or production from the neighbors maybe, and of the capacity in the grid. So this is a model that we made to demonstrate how a safety net for the grid will work, because we feel that it's necessary to have a safety net if we are so dependent on controlling the energy consumption per charging session and per household. So basically what I will first show you is what will happen if we don't have a safety net in place. So if you have the household and there's energy consumed just for regular energy usage, you can see per cable that the demand is increasing, and the middle one is the transformer unit, and you can see that we can, this one is not working.
There's an outage.
There's an outage. But anyhow, you can see the energy on the transformer increase, but there's no problem if nobody drives electric, because there's enough energy capacity in the transformer. We have about 50 to 60% overcapacity in the Dutch grid. But the thing changes when you start to drive electric, because every car that you add adds the power demand of 10 households.
So that's 10 kilowatts, 11 kilowatts of the charger.
Of power. So that 50 or 60% overcapacity is filled up really quickly and causes an outage. And here, this street is without power. There's no lights and there's no charging taking place. And this person can't even connect a charger at this moment because the grid operator will not allow it, because it doesn't fit within the grid. So now we do have the power in the entire neighborhood. That's nice. Now I can actually show all the power demand. And what I wanted to show is that if you start driving electric in a certain number of occasions, then you can overload the transformer as a whole. And if that happens, the entire neighborhood is without power. Even this street where hardly anybody is driving electric is without power. So that's something that you don't want and that you need to prevent. And that's where this safety net comes into place, which we developed as a separate mini computer that we add to every charging station and also to the measuring device that is in the transformer unit. It's just a mini computer that on the transmitting end is only listening to what is being measured and is determining whether or not the situation on the transformer is safe. And if it's not safe, then it starts sending a signal to all the connected chargers that they have to reduce their charging speed because there is an emergency situation. And without the grid shield active, I just showed you that with this number of cars, we had an outage on the entire grid. But because there's now a safety net in place, we can put that same load on the grid again and see the demand change. But now what is happening, you see here the flashing light, is the grid shield that is intervening and sending a signal to all the connected cars. And the situation is now stable. It's reached a safe level. Now we can even add extra cars without any problem. And we can have them all charged, because every time we exceed either the cable limit or the transformer limit, a new signal is being sent. And the charging speed is reduced a bit to make sure that there's no outage. And this way, everybody can be connected to the grid. Everybody can drive electric. Even this person who doesn't even have a car, if we would assume that they have a car, it would all still fit. So this is really the benefit of having a safety net. Our basic assumption is that smart charging will solve any of these overpower issues because you have controllable charging stations in place. But whenever something unexpected happens, for instance, those uncontrolled loads of the households become a lot bigger, or the connection for the smart charging of these stations fails, or if there's some outage on the local production, there will be no problem. Even if all the cars are charging, something will kick in to keep it safe. And this, we now develop this only for public charging, but we're also looking into how we can connect this safety net to home energy management systems, where we would be able to have the home energy management system decide whether or not to pause the heat pumps or pause the charging a bit, delay or do anything else that they might have in their capacity. We don't care what it does as long as the power demand is reduced and the stability of the grid is maintained. Then everybody can continue what they wanted to do. Only the flexible parts will be a little bit influenced. And of course, this will only last for as long as needed, because the cars will still be charged. At some stage, a session will end. And then again, a recalculation takes place, because then there's no outage anymore. And a new signal will be sent to all the remaining charging sessions so that the normal charging will resume as soon as it is possible. And that is, of course, very important, because it's not our goal to intervene with the charging sessions. The only goal of this invention, so to say, is to make sure that no unexpected things can happen.
Okay, to conclude, what we're doing at ELAAD is we're responsible for the grids. We have a high uptake of e-mobility in the Netherlands, but we see it in a broader perspective. The electric vehicle should be part of the energy system. For this, we developed some standards and protocols such as OSPP, but testing is also very important. Testing if it works, if it's interoperability, if you can use it both in the Netherlands and in other countries, but also testing on cybersecurity, for example. There is a lot of focus on the numbers, how many vehicles are driving in your country, and we're doing better than in that country, or in charging stations. But as Mariscou stated, see it in a broader perspective. There's also a movie shot at the city of Utrecht. They're doing very large tenders, and not with the state-of-the-art of today, but also the state-of-the-art of the future. So be ready for new techniques as vehicle to grid. So what you can do in your country, in your municipality, of course, buy, if you can afford it, an electric vehicle, or wait a little bit till they're reasonably priced. But don't focus only on the electric vehicle, but also try to integrate it with your energy system. So you might optimize that a little bit on grid reduction, or also cheap prices when you are charging. That also helps your local grid operator. If you are a grid operator, develop a vision on how you're integrating all this and reach out to the municipality. What are their plans? Are they doing large tenders? What do you foresee not only today and tomorrow, but also in the coming years, and integrate it also with the generation of electricity generated by rooftop solar or users as heat pumps? If you're a politician, well, this summer there are European elections, and a lot of standards are made in Brussels, and we're often complaining a little bit on Brussels because it's red tape and bureaucracy, but it also can really help if there's standardization. So a new vehicle in one country is able to drive in a second country if you're on holiday, or whether if you're there for business. But also if you purchase it on a second-hand market, that you don't have hassle with different systems. Things should be smooth, and collaboration between countries is essential, and I think that is an opportunity to show where Brussels has an added value. So thank you very much. if you want to go testing, reach out to us. Yeah. It is free because we want to get to know you, and you might have also some new ideas which we haven't discovered yet, and how we can integrate them. And on the other hand, it helps if also new products don't have child diseases in them.
And if they do, it's fully confidential. We won't be telling anybody. We do write a lot of reports, but we don't write any reports on testing outcomes stating the name or the manufacturer.
No naming and shaming.
No, because that's not our goal. We just want to make sure that everything functions as it should, and that any unexpected events are discovered as early as possible, so that you will buy a charger or a software system or a car that is secure for using.
But if you're not coming for a physical test, you can also reach out to our internet page, ElaadNL, and see some publications on smart charging, but also on cyber security. Thank you very much.
Thank you.
Děkuji pěkně za dosledování dalšího videa a také děkuji velvyslanectví Holandského království za zprostředkování možnosti tato videa natáčet. V dubnu, v půlce dubna roku 2024 bude obchodní mise do Holandska, kde bude možné navštívit právě firmy, respektive organizace, jako je tato. Bylo to pro vás zajímavé téma? Ocením vaše názory, komentáře a dotazy dole pod videem a budu moc rád, když se přidáte mezi odběratele tohoto kanálu. To je to základní, co můžete udělat pro mě jako nezávislého autora. Jsem Jan Staněk a od roku 2019 se snažím inspirovat milion lidí k přechodu na elektromobil a čistou energii. Mějte krásný energický den.